Alright, so today what we're going to do is take a look at area and perimeter, but not just regular run-of-the-mill shapes, ones that have sides that are segments, the classic rectangles, the kinds of shapes that you were looking at, the regular polygons, those things. We're going to get away from those and say, well, what if we have some different types of shapes? What do we do with that for area and perimeter? Okay, so we're going to call this area and perimeter of closed curves. Okay, so now we're really looking at, again, something that's not very linear. So the first thing we're going to do is develop some formulas. Okay, so I want you to go to my website and go to unit 7, and we're going to click on poly area. So we'll go ahead, and if Mr. Collins will go ahead and pause this, then wait till you guys get all in the right spot, then we can go from there. Okay, so I'm going there now. And this doesn't work very well on the tablet, but we'll get you in the right spot. So there's poly area right there. Okay, so I'm going to pull this up, and here's what we have here. So we have, get on this side. So we have a triangle inside of remember we call that inscribed. Inscribed a circle has the area of polygon 1 there, 256. And represents the number of sides that polygon has. So as it says in the directions here, you're going to slide in, and you're going to notice how the area of the regular polygons change, and the shape that is formed as the number of sides of the polygon increases. This should only take you a couple minutes. So we'll go ahead, pause it again, wait a couple minutes till everybody's done, and then we can talk about it some more. Okay, so I don't know if mine worked here, but it looked like it might have not. So what I'm going to do is fix this. Hang on. Okay, so I couldn't get it to work on here, so I just use it on my computer. So this is the kind of graph you would really have to kind of zoom out on it to get it, because obviously these numbers are pretty good size. So as we see here, this shape kind of goes up, goes up, goes up, and it's just kind of bending a little bit. All right. So let's think about what happened. As you looked at this polygon, you should have noticed that as you get more and more sides, the polygon approaches what kind of a shape? What does it get close to? Well, hopefully you saw that it gets close to a circle, right? Because that's what is happening there. And the area, as a number of sides, increases, but now it's just kind of starting to turn a little bit. And you should see that maybe if I had like a 30-sided polygon, that would be really close to a circle. All right, so that area is going to kind of level off a little bit. So we look at that, and in mathematics we say that the area is approaching what we call a limit. It's getting to a certain value. As the number of sides increases, it's getting close to maybe a value, or getting close to a certain value. All right, so let's go back to this and talk about this a little bit. So it talks about that limit here on your document, but if we take and have again a polygon, a regular polygon, right, that has all these sides on it, okay, and it starts to look pretty circular. We know that the area for one of these we found by taking that triangle, right? So we talked about being perimeter of times the height. This is the height, right? Divided by 2. Okay. Well, if that becomes circular, then the perimeter of that polygon or that circle becomes a circumference, right? So you should know that circumference is the same as perimeter, just the circumference is in a circle. Okay, and if you're not sure what the formula is for circumference, we can look it up. All right, but in this case, I'm just going to tell you that it's 2 pi r. Okay, and there's ways to come up with the circumference of a circle also. And maybe you've done some of that before, or you've looked at the circumference. Okay, so that's what the perimeter is of the circle, circumference. So let's put in here 2 pi r for our perimeter. Okay, now h, let's talk about h for a little bit here. So this is h, right? So as the, and this would be r here, as the number of sides increase, the number of the length of this base here decreases. So these triangles get infinitely smaller. So then we could maybe draw just one, you know, look just like this. It'd be really, really small. Okay, and we could even get smaller still, right? But as we did that, one thing that we might notice is that this h gets really, really close to that r value. So there's a number of things happening here with this whole idea of a limit. First of all, we said the polygons are becoming more circular, so they're limiting out to that. We said that the area starts to limit out. It starts to level off. And then this h value gets really, really close to being an r. So let's say that we do that. Okay. So now we have the area equals 2 times pi times r squared divided by 2. Cancel that out. And there's our formula for area. All right. So we basically have two new formulas here, right? Area of a circle and circumference of a circle. So we should add those to our formulas. Let's see if I have those here. Not sure that I do have our formula someplace. I don't think I wrote those down. That was probably the day I didn't bring my tablet with me. So you know all those formulas that you have with all the polygons, right? So you want to add to that circle. And underneath it, we're going to go circumference, which is 2 pi r, and area, which is pi r squared. So there's two of our new formulas, all right, for circles. Okay, so now we have this wide range. We have all these polygons, right? And now all of a sudden we have a closed curve, which is a circle. Okay, so add that to your formula sheet because you can use it. And just for the heck of it, let's do a couple of examples with that, right? So, of course, when circles, you know, we think of pizzas, right? Because most pizzas are kind of circular, though I kind of like square pizzas myself. But most pizzas are kind of circular. So if we have one like this, and we have a diameter, you know, maybe you're getting a nice one here at Photano's or something, right? It's got a 14-inch, okay? And if we want to find the area of that, right, we're simply going to do this. We're going to take pi times radius squared. So that would be pi. Radius, remember radius is going to be half of that diameter. So that's going to be 7 squared. So we get 49 pi. And a lot of times area is left in terms of pi, but I'm going to go ahead and figure it out. So I'll have 153. I think it was 0.9. Yep. For my area. Okay, that's the whole darn thing, right? If I want to find the circumference, which of course would maybe represent just the crust, maybe you know, you hate everything else about the pizza light, but you like that stuffed crust or whatever it is. I like crust, but I like the rest of the pizza too. So we're going to go 2 pi r for that. And we could just take diameter times pi, but I kind of like to keep my formulas consistent since this is 2 pi r and this is pi r squared, rather than having to have one in terms of diameter, one in terms of radius. Let's just keep them all in terms of the radius. So this would be 14 pi, right? And again, we can figure that out. 14 times pi equals 43.9. Okay, so this would be, of course, inches, and this, of course, would be inches squared. All right, and we could play around, and if we knew how thick it was, we could find the volume of it, how much you're going to eat, and all that. But we're not ready for that yet. So that's how you would find the area and the circumference of a circle. You're just going to go ahead, excuse me, and do that part. Okay, so we have that taken care of. All right, we got area and circumference taken care of. Circles, we derive those formulas. The next thing we're going to do is talk about what happens if we have a shape that looks like a pond. Okay, what about that? What about a pond? Okay, well, let's do that. So here's what I want you to do. I want you to go into GeoGebra again, or not to GeoGebra, sorry, into the website, and we're going to get something called salmon. And you probably pulled that up already, and you can see that that is something that most of you have probably been to, right? Salmonberry Reservoir. Okay, so Salmonberry Reservoir is a pretty good example of something that looks like a pond, all right, or a small lake. All right, I myself lived here since '99. Never been to Salmonberry Reservoir. Ridden by it a number of different times on our bikes as we climb Pittsburgh Road, but I've never even been over there. So anyhow, there it is, Salmonberry Reservoir, and heck, we want to find the area of that. Okay. Well, the problem is that there's no formula for this. Look at this shape. I mean, it's not circular. It's not a polygon. How are we going to find the area of a reservoir like that? So we use squares. And remember how we talked about with the polygons, how we said, hey, let's break it down into just some shapes that we know. All those other ones, those kind of U-shaped ones that you did on your assignment, we did in class, we broke them down into rectangles, right? So in this case, we're breaking this Salmonberry Reservoir down into squares, all right? And you might remember that day when we talked about it, I said, hey, area is square units. And here's why, because we have squares right here, okay? So we're going to use these squares to find the area of Salmonberry. Here's what I want you to do. I want you to count all the whole squares inside Salmonberry Reservoir. All right, so go ahead right now, pause the video, count all the whole squares. So what do I mean? I mean, anytime you have a square that's completely inside the reservoir, count it. What the heck? Okay, so I guess I thought I'd pause this video. I'm not exactly sure where we left off at here. But let me see. So I'm pretty sure that we went and we talked about how to find the area of this circle. And then I paused it. And so hopefully that's where I left off at. You should have the notes here. Not having much luck with this tablet tonight. Okay, so again, I'm hoping that you got the area and circumference formulas for the circles. I'm pretty sure you did. I'm pretty sure you did the pizza problem. And I said, what about a pond? And that's what we're going to take a look at next. So I think that's where I hit paused, and I might not have unpaused it. If not, Mr. Collins probably explained to you how to find the area and circumference of these 14-inch pieces, but I'm pretty sure you got it. All right, so let's see. Here's what I wanted you to do. I wanted you to go back to my website, okay? And you're going to go down here to salmon, and you're going to pull that one off, okay? Now, as I was saying, this is something that you're probably very familiar with, Salmonberry Reservoir, all right? So many of you have probably even been there before, all right? And this is a great example of a pond or a small lake, all right, that we want to find the area of this. And it's not a regular shape, right? It's not anything that looks like a polygon for sure. It doesn't look at all like a circle. So how are we going to find the area of that? What if we need to find the area and we're not sure what it is? So one of the things we talked about is if we don't know how to find the area of it, we break it down into shapes that we can find the area of. And we make those shapes very easy. So that's what I did. We put a grid over this, right? So now we have a grid over Salmonberry Reservoir. So that helps us because now we can break it down into these shapes and find the areas. We also said that all areas in square units, and notice we use squares. And this is the reason why, is because area is broken down into squares, and that's why you find area with square units, okay? All right, well, that's one of the reasons why. So anyway, here's what I want you to do. Find the number of squares that are completely inside the reservoir. So we want to find it, we call that whole squares. We want to know how many whole squares are completely inside the reservoir, all right? If they're touching anything that's not part of the reservoir, we're not going to count it. Okay, so go ahead. We're going to pause the video and count that now. Okay, so I counted them. I don't know how many you got. So maybe you could go ahead and share what you got. How many whole squares did you get? Okay, and then we'll just take an average of those. So let's pause the video, go ahead, see how many we get. All right, so I counted 7, all right? But you might have a different answer, okay? So it kind of depends on how many you actually see there, but I counted 7. All right, now we're going to take a look at partial squares, okay? All right, so now count your partial squares. So any square that has just a little bit of body of water in there, we're counting it, okay? So if a square has water, we're going to count it. Now over here we have a little bit of an inlet here, all right? I think that's what that is anyway. And it looks like there's some water there, so we're going to count this square and this one, all right? Count those as your partial. Okay, so we're pausing it and counting them up. Okay, I counted about 25. Okay, so there again, you could be off by 1 or 2. All right, it depends on how, maybe you count a little bit differently. But there it is. So we have 7 whole and 25. Well, now we need to come up with a rough estimate for the area. So exactly how many squares is it? What do we do? How do we come up with an answer? It's pretty obvious what we're going to do with the whole squares. Nothing. But what are we going to do with the partials? What do you think? Yeah, we should divide the partials in half. We're simply going to take half of the partials, all right, and see what we get. So here we go. So we have 7 plus 12.5. So we get 19.5 square units. Right? That's the area. All right, 19.5 square units. You say, well, okay, that's nice, but wait a second. What is this? What does that square unit represent? Well, down here on the bottom, we see that 50 feet equals 1 square length. So then we would know if 1 square length is 50 feet this way, we know then we can find the area of one of those squares, right? You should be able to do that. Once you know the area of 1 square, you should be able to find the area of lake. So go ahead and do that right now. Take the square units you get in that area and figure out what it is. We'll pause it, have you figure that out. Okay, so hope you came up with something. I did. 19.5 times 50 squared, all right, 2,500, and I got 48,750 feet of area. All right, so that'd be square feet. Interesting. Okay? That's how we can find the area using squares. Is there another way? Well, of course there is, but I'm not sure how I can be able to explain this to you using this particular on the tablet, but I'll give it a whirl. Okay, so let me make sure I'm recording here just to make sure. Yes, we are. You're going to use what is called the polygon tool. Okay, so you come up here and you're going to make a polygon. All right. We're going to outline the pond or the reservoir here by just kind of clicking along the reservoir, and we get to a certain spot. I'm just going to kind of click my way back as close as you can. You're going to outline this, and the close the better you are to outlining it, the better it is. So there is a polygon, okay, that pretty much resembles Salmonberry Reservoir. Now watch this. We're going to go here, area, tap on that. It tells you, of course I can't read it, so let's see if we can get it to read. It says it's 55.93, but something happened when I did that. I see that hang on here, one of these points got messed up. See, that's why I don't like doing it on the tablet. So you're going to get a different answer, and this thing's messed up. I think it's this J point that got messed up. There we go. Okay, so let's see if I can just move this now. Come on, get it over there. You'll be able to have better luck than what I'm having, because it's just the way the tablet is. Come on. Here, let me do this. I'll fool it. Looks like I'm guessing that it is 75.39. I'm pretty sure that's what the area is. Okay, 75.39. See if I can kind of close this up here. All right, so if we take that now, I mean, that's GeoGebra units. All right, so we'd actually have to figure out what this is in GeoGebra units. Okay, but we could, and then we could come up with the area. All right, we could also measure the perimeter of this, so let's do that. So the perimeter is whatever this thing is. Hopefully, see if we have any luck bringing this around. I'm not sure that I will. Oh, I'll cheat again. Oops. 50 feet equals 1 square units. Let's see what we got for perimeter. Oh, there it is, 50.84. Okay. So area, we think is 75.39. Perimeter is about 50.84. Okay. So, that's how you do that with fine and irregular shapes. Hopefully, you might have enough time to work on your assignment. If not, hand it out anyway, and we'll get started with it. And then I want to work on some things on Monday with you, making sure you kind of get what we did here. And have a great weekend.